In this video, I'm going to share an interesting project with you all, a metal detector circuit using the NE555 Timer IC. This is a simple BFO-type metal detector, and you can use it to detect coins, metal objects, and even buried treasures. The full circuit working, component list, and step-by-step explanation are all covered in this video. I'll explain everything in detail, so watch till the end. Here is the PCB version of our metal detector circuit, fully assembled and ready to use. But before we go further, let's convert this into a manual circuit connection so that you can clearly understand how each component is connected and how the whole circuit works, step by step.
First, let's look at the power supply section. This circuit uses a 12-volt battery, BT1. C1, a 1000 microfarad capacitor, stabilizes the battery voltage and supplies instant current during sudden load changes, keeping the power supply clean and stable for the rest of the circuit. D1, the LED, works as a power indicator. It lights up as soon as the circuit is powered on.
Now let's move to the heart of the circuit, the NE555 Timer IC, configured in Astable Multivibrator mode. R1, the potentiometer RV1, and capacitor C2 together decide the oscillation frequency. RV1 is the frequency control. Adjusting it changes not just the sensitivity of the detector, but also the tone. From the output, pin 3 of the NE555, a continuous square wave signal is generated. This signal passes through R4 to the base of Q4, a BC557 PNP transistor. This transistor then amplifies the oscillating signal, and the MOSFET drives the search coil. This coil is made of thin wire with multiple turns. A couple of resistors limit the current to protect the coil from damage. A pair of diodes safely clamp the back EMF spikes generated during coil switching. This acts as a protection mechanism. When a metal object comes near the coil's magnetic field, eddy currents are generated in the metal, which slightly changes the coil's inductance. This change is the basic detection principle behind this circuit. The small change in signal from the coil is coupled to the next stage through capacitor C4. U1A, an RC4558 op-amp, forms the first amplification stage. R10, R11, R12, R13, and capacitor C5 together set the gain and filtering. After this comes RV2, the potentiometer. This is the gain control, used to adjust the overall sensitivity of the detector. U1B, the second op-amp stage, along with R14, R15, C6, and C7, further amplifies this weak signal up to audio level. In the final stage, C8 couples the amplified signal to Q3, a BC547 NPN transistor. R16 and R17 control the current. This transistor drives the speaker, so when a metal object is detected, the speaker produces a beep sound. So friends, now you understand how simple it is to build a fully working metal detector circuit using just an NE555 IC. Remember, RV1 sets the frequency and RV2 sets the gain and sensitivity. Like, subscribe, and share this video with your friends. See you in the next video. Thank you.